Find the value of the positive constant c such that there are critical points at t equals 0, 1, and 2 in this given function. At a critical point, the first derivative is equal to 0. Let's begin by computing the first derivative of r of t. We have several functions nested within each other. Let's use the chain rule. The outermost function, the outermost thing I can see here is that power of 2. We bring that 2 down, ln ct² minus 2ct plus 2c. We've now dealt with that square. Deal with the ln. Ln differentiates to 1 over something. In this case, 1 over ct² minus 2ct plus 2c. We're done with the ln. Now differentiate that polynomial inside. 2ct minus 2c. There's a lot of different things being multiplied and divided together. Let's bring these individual pieces together. There is a common factor of c among all the terms in the numerator and denominator. Let's cancel a factor of c from each term in that fraction. I think that's as much as we can simplify that first derivative. There's probably other ways you can simplify it by factoring, but it doesn't make that big of a difference here because we're going to substitute in these critical points and setting the first derivative to 0 and solving for c. Simplifying the first derivative just makes this part of the work a bit easier. It doesn't matter which critical point we begin with. I like to use 0 because it just makes a lot of things 0. It helps us save some time on an exam. And simplifying, we have 2 ln of 2c multiplied by -1. We can divide both sides by -2 to isolate ln of 2c. To get to that 2c, which is locked up by that ln, we have to exponentiate both sides of the equation. Now e to the 0 is 1. It's so important that we remember that. 2c equals 1. Divide both sides by 2, we have c equals 1 over 2. This is the answer, but if we wanted to check our work, we can use the other critical points and see if we arrive at the same answer. At the critical point, t equals 1, we also expect the first derivative to equal 0. That huge fraction cancels very nicely. We have 2 minus 2 in the numerator and a non-zero denominator, so then that whole thing becomes 0. Multiplied by 2 of ln c, we know that c is positive, so we're not breaking any mathematical rules here. So 0 times something equals 0. T equals 1 actually doesn't help us because we have 0, 0. Let's try the other critical point, t equals 2. And simplifying, we have 2 ln of 2c multiplied by 1. Equals 0. We isolate the logarithm by dividing both sides by 2. And in order to get to that 2c in the logarithm, exponentiate both sides. 2c equals 1, divide both sides by 2, and we get the same answer again. C equals half.